If a line touches a circle at exactly one point P, then the line is perpendicular to the radius OP. Let's draw a circle. O is the center of the circle. P is a point on the circle. Now we draw a radius named OP. Let's draw a tangent at point P. Q is a random point on the tangent. Now we connect both points O and Q with a straight line. Therefore, OQ intersects the circle at a point. Let that point be R. From this picture, we can say OR is less than OQ. Because R is a point between O and Q. Again, OR equal OP. Because they are radii. Therefore OP is less than OQ. As we previously mentioned, Q is any point of the tangent. Therefore, among all line segments drawn from the center of the circle to the tangent line, the segment OP is the shortest. As we know, shortest distance is always perpendicular. Hence, we can say the tangent at point P is perpendicular to the radius OP. That means, if we draw multiple lines, we can clearly say OP is the shortest distance from point O to the tangent. As we know, among all line segments drawn from an external point to a straight line, the perpendicular segment is the shortest. Hence, we can say the tangent at point P is perpendicular to the radius OP.